AudioMancer starts with a simple idea. Take a written story and help turn it into an audio experience. The workflow begins with a project. Each book or text gets its own workspace, with its own files, settings, generated data, and progress. The app keeps the steps visible, so you always know where you are and what still needs to be done. Before processing the book, the app can be configured with AI profiles. AudioMancer is designed to work locally first. The project files, workflow state, generated outputs, and production structure stay on your machine. When stronger language understanding is useful, the app can also connect to online AI models for cleanup, chunking, translation, character discovery, and speech block generation. The first real step is bringing in the source material. Here the app opens a book file and extracts the text into the project. The goal is not only to read the file, but to prepare for audio production. Raw book text is often messy. It may contain page breaks, repeated headers, broken paragraphs, or formatting artifacts. AudioMancer separates this into a cleanup stage, so the operator can inspect the extracted text before moving forward. The deterministic cleaning works very well and is able to eliminate the artifacts and metadata from a variety of inputs that is supported by the app: TXT, PDF, docs, ODD, ebook formats. Text cleanup can be deterministic or with the help of an AI model. Here I use the GPT 5.4 Nano for cost efficiency. We can use a local model, so we can have zero costs. The app also displays the progress in token consumption. Every step can be interrupted and resumed even between app startups. In this way, we can manage long-running sessions and operations. As we can see, the AI-based cleaning result is very good, with paragraph preserved separation. After cleanup, the text is split into larger chunks. Chunks are not the final audio blocks. They are working sections of the book, large enough to keep context, but small enough to review and process reliably. The app shows the chunk list, the selected chunk, and the generated output side by side. For long books, this structure turns one huge text into manageable parts. We have the option of deterministic chunking. It will create paragraph-level chunks or AI-based chunking. Here, we can leverage the power of an LLM, and we have 3 chunking strategies: paragraph, meaning, and scene, which is extremely important for the next steps. The next step shown is AI translation. AudioMancer can translate the prepared chunks while keeping the workflow organized. Each chunk has its own original text, translated text status, and approval flow. The translation is not treated like a black box. The user can inspect the result chunk by chunk, approve what is ready, and keep track of what still needs attention. Here I use a more capable model, although it's not the most capable. The translation will preserve the meaning of the original text adapted to the specific of the translated language. Here the chunking operation has importance. The AI model bin feed with chunks that have an overall meaning for superior results. After AI-based translation, the user has the possibility to review and change the translated text. A dual-panel original versus translated window simplify the operation. After every chunk translated has been analyzed, it can be validated, or all the translation can be approved on one click. Once the text is prepared, the app moves into character discovery. Here the AI analyzes a story and finds speaking characters. It builds a character list, keeps evidence from the source chunks, and lets the user review or adjust the results. This is not only about names. The app is trying to understand who speaks in the story, what role they have, and how they should be represented later in audio. Here, again, we harness the power of an LLM. Multiple passes create a list of characters alongside their attributes. User can also manually add, edit, or delete a character. Also, the application presents the evidence text where the character is discovered. Observe the plethora of details and attributes of every character that are extracted. The AI provides superior performance in structural narration analysis compared to manual evaluation. This characters and attributes extraction will be used later to create a specific custom voice with tones that will be specific to that character. This is the main novelty and strength of this app. It creates the voice of the character for an elevated audio experience. After characters are known, the workflow moves to narrator voice setup. The narrator voice is the main voice of the audiobook. This page is where the narrator profile can be prepared, tested, and adjusted. A short sample can be created first, reviewed, and only then used as part of the larger workflow. We have some predefined voice presets, but also the user can create new ones. The creation method is straightforward. It will describe the voice. And remember, the whole application can run locally and offline. Let's generate a voice and hear it.
The hall fell silent as the final lantern dimmed, and every step carried the weight of an unspoken decision.
The next page is character voices. This is where the narrator and the discovered characters start to receive voice samples. Some characters may get their own voice. Others may reuse the narrator voice, depending on the style of the audiobook. The point is flexibility. A simple project can use one voice. A richer project can prepare different voices for different characters.
The evening settled over the old house, and each voice carried a different shade of memory.
Observe that the generated sample respects the voice design prompt. We can specify if the voice should be of a young female. It should be polished, imperative, warm, low.
The evening settled over the old house, and each voice carried a different shade of memory.
Let's hear other character voices to better understand the magic of this app.
The evening settled over the old house, and each voice carried a different shade of memory.
One important feature is that we can translate and generate not only the text, but also the voice. The translated voice will adapt the language tones for a truly theatrical narration. Let's hear the German text spoken by the same character with the same voice.
Sie traten kurz nach Drenthe in den Orbit um Bukhari Ophon ein, nachdem er den Weg zu seiner Kabine gefunden und einen von Brandy unterstützten Schlaf begonnen hatte, der von Visionen der Holos unterbrochen wurde, die er noch machen musste.
After voices are prepared, the app moves to speech blocks. This is where the text is split into smaller pieces that can later be sent to a text-to-speech model. A chunk may contain narration, dialogue, and attribution text all mixed together. AudioMancer separates these into speech blocks. Each block has text, order, and a speaker attached to it. That speaker can be the narrator or one of the characters. Observe the performance of the AI-based operation. The dialogue is extracted from compound statements, and the character is correctly attached to that line, or the narrator. The later audio stages are still being prepared, generating audio for each block, approving the results, and assembling the final audiobook files. AudioMancer is being designed as a self-contained desktop app, with separate releases for Windows and Linux. It runs as a completely local application, but also can use online AI models only if the user wants to use them. Thank you